just speak Chinese.
那个今天应该说这礼拜的话，我们就是有邀请那个国立新加坡大学的那个教授 Frederick Kim， 然后他来我们所上给我们的1个礼拜工作营。那今天大概工作营的主题的话，就是你会看到那个 Frederick Kim 的话，他就会用一些machine learning的一些tool，那你会看到它不是用来像一般的那种 engineering 去生成是一些 AI 图像。那它是用来做一种分析，它分析的时候，它去了解每一个城市或是每个 building 的背后的一些文化，或是它的一些语言，然后它用它来当成去变成一个 tool， 然后一个 design 的一个 process 或是一个 strategy， 然后它会慢慢发展出一个系列的一个系统，或是一个它自己的属于它自己的一套方法，然后去用在之后，他比如说想要去做一些building design， 或是法商比赛的一些重要的一个元素，然后用在比较创意的一个方面。然后他今天的主题是比较大家可以把它想是一个 deep architecture。那我们就先欢迎 Professor Kim。
Thank you. All right, so I'll start with how long do we have today actually? Like how long is the...
Yeah, it's like an hour.
Okay, I'll go. So, thanks for inviting me here. I'm very happy to be here to present some of my work and my friends. And also thanks to Professor Yuan and Junhao for inviting me and also have opportunity to work with the students here. It's quite exciting. So the title of the lecture is Deep Architectural Form. Hybrid thinking from human intuition and machine perception. So just quickly, my background actually expands from, I'm a designer, I call myself a designer, but I'm also interested in AI. And a lot of work that I do, I focus a lot on form, architectural form and built environment. And also interested in this kind of a physical virtual hybrid. So there's kind of 3 kind of main work that I kind of focus on, and also I have a creative practice with Mikhail Ioannis, who is also a colleague of mine from EPFL, who's doing a fellowship in ETH right now. And we also have this practice, which is now also part of the lab at NUS. So, and then we have about like 6 members in our lab, 6-7 members in our lab working together. So I start with this graph where this diagram actually illustrates the kind of the historical progression of technology in architecture, these digital tools, and you can see all these different waves. And the red part is actually AI, when there was a architecture machine by Negroponte, and then you can see that it kind of dips down and then goes up. So all these tools has been, used in our field. And these tools and theories over time developed, and now it's really like booming up with this red line going up with the AI and machine learning. So basically the tools actually go through cycles. Sometimes they come back and then they develops further. So like AI is increasingly becoming like part of our world, and we witness this kind of reborn interest in using such machine as kind of creative partner and problem solver instead of just using machines to make drawings. So the questions that we have is like, how can we actively shape our interactions with AI's pervasive influence across transcalar design, not just about one scale, but across the discipline in our field. And how we can actually, the question is like how we can actually not lose control and actively take a leading role in how we can develop these intelligent design tools with it. So that we believe that the answer is the bridging of centuries of architectural knowledge that we have as an architect and into our ways of training an intelligent system. So this first project I'm going to showcase might have already seen actually from Professor Huang last year. So there might be some overlap. But I have some new parts too. So you know, like how as an architect we use images as inspirations, right? So these are some of the books that architects showcases what architects have used in their design process. But for me, this image was quite impactful because this is the extension of this alpine hut to an old one to new one. And this was like the first project that I built as a student when I was doing my master program. So it was creating this hut in Slovenian Alps. And the idea was actually coming from that image. So like how these vernacular form gets extended into a new one, and then using the terrain, like it adapts to the terrain, but also plays with this geometry of the roof to create the gaps for lights, and also thinking about how these gets actually transported. And then here you can see some details. Actually inside, when these cabins step backward, they actually, the surfaces align to become an extension of the surface. So here you can see this image. I've also slept in here. You can see kind of the facade details, and also how this was actually the actual scene. But I think there's a sound, but sound is not working, so I don't know. Yeah. So maybe I need to actually do it in my end.
Yeah, we tested it used to be.
Yeah, it's from me, right? Yeah.
Can you check if the sound
Yeah, I
comes
think.
out from HDMI?
Let's just check. Okay, sound is not working. That's it, right? Projector. Oh yeah, okay. So maybe my sound is actually better. Sorry for this. And so this project was kind of the first project I was working in 2015. It's quite a fun, also like student project becoming in real life. That was quite experienced. And then we had a chance to revisit this project in a completely different context when I was doing my PhD with Professor Huang at EPFL. And so basically we use all these images from this Swiss Alpine culture. And in the beginning of the student, this was a kind of student research studio. And in the beginning, we asked the students to actually draw what they think of what Swissness is. So here you can see a lot of different sketches done by students. Sometimes there's a lot of red. Sometimes there is like a building out of wood or stone. So this was kind of the vision that they had as a Swissness with Alpine hut. So this became very important topic throughout the research, because at the end, the ultimate question was, can the machine actually understand Swissness, right? So this process of going through this, I'm sure you guys know, back in 2020, there was a gun that we were using as a kind of creative agent, and back then, this was a process of interpolating it and also using these animations that are interpolating from different images in Latin space, and then actually kind of freezing into one moment to actually understand what could be a new invention that gets created out from the images, right? So this one, students actually go through as the eyes of architect to understand this image into actual architectural elements, and then also looking with what the languages that we use. So this was before large language model, where it was a natural language processing to understand how image might be related with the text. And a lot of different elements were identified in this process. But my research actually here in this research actually focuses on how to transform 2D image into 3D. So nowadays it's very fast to translate that, right? You just have to put images and you just type it in, make a 3D model, it just generates 3D model. But this happened all within 1 or 2 years. So back then, I still wanted to bridge this kind of knowledge that we have as architects. So I looked at it through the lens of perspective geometry, descriptive geometry, if the machine can actually understand this. So that by curating what machine generated in this perspectival view was quite, you can see these patterns of the images getting generated in specific views because of the data set that was trained. And that you would create this kind of families of refuge that is used to understand 3D information from the interpolations from one viewpoint to another viewpoint. So here you can see this was back then, like a few years ago, when we're trying to understand how we can get the 3D information out of this. So basically we were investigating like different views can generate more information in between the different perspectives. So basically we use this inversive projective method to actually transform these 2D images into 3D. So some script was invented to actually transform one image into 3D information. So here you can see the process of using the script to generate the 3D model in it. So here you can see some models that was created from the image to 3D. And basically in this process, students also identified from the images to understand into a parametric tool. So from the image, they understand the elements, they interpret the elements, and then transform that into a parametric tool, which becomes a tool for architect to design. So here you can see some prototypes, and then this was actually used with the real data, meaning real program, and then put it back into where the Alpine hut is, but going into even the detail of it, of the construction from that image. So even though we were using AI as kind of a glitches, but the scale of the project goes from the beginning to the end of what architects would do. So here you can see the details of the construction details. And then of course, it is also important for us to kind of present this idea. So in the Rolex Center, this was presented as kind of hallucinating this kind of Alpine hut along the Sanas building. And then we had a chance to exhibit this as kind of a one-to-one spatial experience to represent these kind of hallucination of the machines. So here you can see some of the details of the video that was filmed during the Biennale in Seoul, and here you can see some details. But the idea back then, it was like, how can we create this kind of a brain that can actually like dream about these images. But also, I'm very interested in kind of geometry and form, so this apparatus also became a way to host this kind of projects. And this was a detail, well, there's like 2 different modules that actually can transform into, also be easy to transport, but it can actually transform into different modules. So the inspiration was for this kind of, back then it was kind of inspired by this hats that was traditional hat in Korea, and then this was kind of the way to kind of goes with the brain and then hat and all these things. Also during the Biennale, we asked everyone to kind of weave all these patterns, so every pattern was different, which actually been used as and also can be transformed into different geometry, so you can actually adopt a different exhibition format. So we've been, this is still traveling around the world when there's an opportunity, taking different shapes. And this was part of this is something that I'm very much interested in, working with the local artisans, local workers on developing these tools, these installations. And also here you can see some image of that. And yeah, here's just a clip of that video. And then of course, traveling around in different places, taking different shapes. This was in Zurich, but also the content actually traveled again back to Seoul, but became part of the bigger exhibition on talking about Swiss Alps and Korean mountains. So I was part of also creating this kind of installation also to represent this kind of a fusion, interlay between the Swiss mountain and also Korean mountains as part of the representing other researchers. So in this process of using GAN was actually applied into different contexts as a kind of 3 different tests. So one was the kind of primitive hut, and the second is actually the building in a block. And the third one actually is the urban block. So here you can see some examples of technique of using GAN to represent, but this was in the Zurich, in the old city. So every time when we use the tools were developed, so we had to adapt to using these fast-growing kind of algorithms to it. In this case, when we looked at the superblock of Seoul, we were looking at every student was looking at superblock and looking at I'm using the machine vision to understand all these street views. So basically they identified what can they learn from the superblock. But the methodology was very similar, and this work that I did during my PhD is somehow, here you can see, kind of wrapped with all the works that was done with the physical models and the design brain, which was featured in EPFL. And as we go on to this new age of large language model, everything is changed. Now we're using text to image, so we can generate all these renderings that before we had to
The has disconnected.
So I should.
The Bluetooth has connected successfully.
So always technical problem, even though we do AI. So yeah, so basically you can see now back in the day there are people modeling all these things and then rendering, but now it's completely different also world where so it's getting more like accurate, but at the same time sometimes you have to use the words that we don't understand as a human being, but the machines understand somehow. So that's why there's this long text that's why the prompt engineering is invented as a job. So how to use prompting into creating something that is visual, and then also, but something that is interesting is like now we can actually use these tools to imagine some things that we couldn't imagine, kind of hybridizing different concepts. So this is something that we do a lot, exploring like not just like generating an image, but like how can we use these tools to like imagine something that we couldn't imagine. So this was like in 2021, right? Avocado chair. And also astronaut riding horse in moon, right? But now with Team Fu, this is 2023, which just like it goes back into the way Frank Gehry was designing, right? Like he was like crumbling the paper and then he was 3D scanning the model that he was inventing, but now you just plug it in and then you just have your own prompt and then you just create the architecture you can imagine. So a lot of times we try to investigate, as I said earlier in the beginning of the presentation, how we can actually control this. So some of these things that we know also as a computer scientist, using embeddings, like just using few images to generate these ideas and hybridize different ideas, was also kind of testing how people can use this as their own strategies of like using just 4 images of sculpture from Japan and then translate that into an architectural space, right? So this is just some examples of few images becoming part of the text to image generation, and here you can see one examples of changing, also like transforming. Sometimes it's actually also good to actually use this existing images and then do the in-painting and then transform this. So this tool is something that trying to engage with the students how to use this. But as an architect, we basically have our own language of describing architecture, right? So these are some of the examples that has been published by designer and architects on their language of describing architecture. So this one is actually the verbs that Richard Serra uses to sculpt his space, his sculpture, and then other examples, Fashil Mursavi's functional form. She has her own language. FOA also has their own language to describe about their project. So these became kind of like, and now large language model cannot understand that still, right? Like these details. So what exploration that we did was actually working with Francois Blanchard. He's a professor also at our college, and working with his book of 1001 Images. He also even described in 2 words, right? But this was in 2008, right, when he was sketching. He was sketching all this thing, and he was telling me about how experience was when he was sketching all these images. And then basically what I did is I wanted to create my own architectural machine. So like, because especially I'm interested in form, and then how can we use these tools to actually generate these different vocabularies and visualize it, right? So basically what I did is I tagged every 1001 images with the 5 different words, categorizing from entity, number of the entity, what are the shape, what is the directionality of the shape, what is the operation to shape that form, and then what is the effect of it. So these words were kind of understood by studying other architects, and then basically I tagged along all these words. Like I think it took like 1 or 2 months, but because every time I tag it, sometimes I forget, so I have to go back. But it was a job that couldn't done by 2 people, because it's my language, right? So if I do this, you will have a different language, right? So this was a process of doing it, and then here you can see the affinities between the words. So the stronger the connections with the word means that we can predict it that machine can actually generate this consistently. So some of the tools, some of the tests here, like on the top, it actually be very consistent in generating these images. And as you go on, like if you use the words that are not very connected, it creates more diverse images. And then of course, by creating this kind of matrix, you can actually hybridize different words to generate more images that we couldn't imagine right away. And then it also gives kind of a way to get inspired by these images. So here are some samples of using just a cuboid and then mixing with different verbs. And of course, this can expand to like endless way of generating different forms, right? So suddenly with this tool, I could basically generate these images like Francois drew now in my own language, describing these geometries. So this was still 2023, but now like you can generate this. It's still hard to generate these images with this language, but now it's easy to actually transform into 3D, right? So this one that was like hand modeling, but now we can actually put an image and then generate it, right? So this process of kind of using existing images, using these large language models, and makes us wonder like, how can we differentiate from you to my work? So I think this is, the authorship is very important in our discipline. So in this process of generating from existing image to something new, this was like kind of a project where we were like thinking, how can the building have a biodiversity, so like there's a birds living together with the human. But in this process, you can see that using Midjourney, there's an endless kind of scrolling and testing, and current models, you cannot actually understand how your progress works, right? So what we did is we created a bot that records every movement to actually create this kind of a DNA of how the image was transformed. So you can see how from one image, the starting image, all these are different moves that I was making to navigate. So in reality, it's a linear system, what we're doing, but when we visualize it like this, you can see actually in a 3D-dimensional space, right? So, and then also with time. So there was one tool that we actually created with the students from the class. So basically we created this kind of platform to understand how the different students take different ways to get to their image at the end from the start of the beginning. So this kind of interface actually helps us to visualize what is the difference between, because at the end, we only see the last image, and the question is, how do we get there? So that's something that this project was about, creating a genealogy of image generation, and then this is actually
Hello, welcome to the comfort
a new
of
project
your
that
Today, I'm going
is
to
a
walk
master
you through
thesis
how this system
project,
uses space, evaluates it,
master
and
thesis
regenerates
project
it
that was just recently
using all
finished
the
last week,
physical
and
steps.
then the student basically tried to use the large language models, but control it in this kind of interface. So like by defining who's the user, by putting an image, you can actually detect what are the light qualities of the existing conditions, and what is the geometry, the space of that image, of that space, the information of that space, and what is the activity that you use, what you're using for, and what is the age group. So she tried to kind of quantify these elements and then created this kind of algorithms to. Yeah, you can just see.
We'll use adult as an example. After entering the basic information, upload a photo of the space you want to evaluate.
So it identifies what are the elements that is existing in the
You
space,
can adjust the indoor comfort
and the system basically suggests kind of optimal conditions.
Meaning adjustments in one parameter may influence
And then it's all correlated between different parameters.
We can proceed to generate the AI rendered redesign. Based on the adjusted parameters.
So basically in that space, it generates as you want it to be. So rather than typing all this text, these kind of interface allows you to control this kind of image generations. So when there's a change, you can just make a change and it will automatically change it.
I hope this walkthrough helps you understand.
So this is kind of another way of actually how we can use these large language model for the architects. I'm gonna go to the next presentation. Okay, so this project is also using images, but this is part of an actual research project. It's a Singapore shop houses, and this is a project that I joined, and then it's getting developed further. But we look at these shop houses using the machine learning process. So the shop houses is basically, everyone knows there's one version here, right? There's a version here in Taiwan, and basically the shop in the commercial program in the ground floor and the living on the top. And by the URA, Urban Redevelopment Authority, there is this kind of a big 6 styles that was established by the government. And in reality, it's actually not that strict, right? So even if the history is within a few hundred years, so basically what we did is they collected all these images, and then there's kind of 4 districts that we collected the images, and focusing on Chinatown as a start, the idea is to actually create this framework of how to understand these images that makes sense for planners and also heritage point perspective, and also as an architect. So they focused on basically just the top part of the images, because on the ground floor there is so much traffic happening. Like there's not the car, but there's a lot of things that hides the informations of the facades. So the focus area was on the top, and then looking at these elements, different elements was used to train. It was kind of segmented in a way that you can you can understand different elements in the facade images. And by having what is there, by looking at what elements are there, you can actually identify what kind of style it would be. So actually at the end, there's more than just 6 styles. You can see all these kind of fine differentiations between the styles, even within the one clusters. So it actually expands, using the machine vision, we can actually understand these images in totally different way than before, because there's actually sometimes the building is built in different time period, but it copies the style from the previous style. So there's a lot of mix of these things that we cannot actually understand by human eyes. So by looking at all these data, and then now we're going to further with these elements, architecture elements. So all these elements are more used for training. So actually, we can actually describe. So it's basically similar with my first project that I showed you about finding more details about the architecture. So what we're gonna do is actually, we're planning on to understand, have more descriptions about each element. And by also using graph neural network to understand this relationship between different elements in the facades so that we can actually go in deeper from the previous research that you saw. And here you can see kind of a catalog of different elements. And sometimes actually, so what we still wanted to use the machine learning to understand these facades. We don't want to like actually look at and then catalog each one and identify different windows, but still also using these algorithms to understand images, going into even deeper with the window, but actually just using these different tools to understand what are the different even types of the windows. So the goal is like, even within the window, there's different types, right? With the current large language model, you cannot identify what are the different types. The idea is like, if you want to fix one also windows, who can we actually go to fix? So everything is somehow going to be tied into this kind of studies that we're doing, and then just using the machines to also like look at the different clusters of different types of windows. So just by looking at just the windows, we can identify what are the different types of windows that are there, but also creating a platform where we can actually understand just by putting an image, and then we have a knowledge of, you can ask the questions to this platform, and then we can have a dialogue with it. So identifying different elements, also describing about, if you go down, like it identifies, and then also get the description of it. So this tool is very useful, so we can not just, like we don't only see one state of the building, but we can actually see all this different time period, right? That adds another data sets, right? It's completely, it's not static, right? So you can actually see different times. And also the one aspect of this tool is actually also to detect what are the changes in facade. Sometimes there's an illegal, moves that owners make that is not up to the standard of the government. So sometimes it's gonna be used as also to detect this kind of, either like sometimes it needs to repair, it will detect what is broken, and sometimes it will detect like what is illegal transformations that the owner made. But also we're gonna work with the collaborators who actually, because all these patterns sometimes has a deeper meaning than what we see. Sometimes it means like family, sometimes it means, so these kind of intangible knowledge will also be used in the part of the training. So here you can see kind of the list of the things that we see from the elements, and then how, like, so combining this kind of intangible knowledge into a physical or architectural elements, and holistically bring these all together. So this kind of my interest also in this kind of vernacular architecture goes also in a different data set, which is flow. This is the 1 kilometer building in Seoul called Seon Sanga. So it's a multi-complex building where there's a commercial program on the bottom, and then supposed to be apartments on the top. So this was from 1960s, going across the whole northern part of Seoul above the river. Here you can see the current state of it. And a lot of this is where basically the manufacturing of Korea happened in the back in the day. So you can see a lot of different clusters of streets and neighborhoods that becomes kind of distinct with another. So here you can see a street of woodworking, metalworking, different shops with just jewelry shops or printing area. So this is really like interesting site where knowledge got developed, and there's like a lot of artisans who are actually kind of forced to move out of this area, right? So there's a lot of initiation that is happening to bringing young with the old knowledge. the generation that has this knowledge of construction, but also this kind of young mind that has a creativity. So one of the first open satellite was created here in the Seon area, and Nam Junbaek is also very famous. We're working with artisan here for his video arts. And here, when you look at kind of inventing one installation as an artist, you can see that different parties are involved in creating this, right? So this creates like a really unique environment where it starts to, in order to create this one thing, it becomes kind of a spatial navigations between different parts of this neighborhood to actually create this project. So what we looked at is look at the processes. So we looked at how we can actually transform a waste into a product. So this became a way to develop this studio, looking at just processes. So these processes were identified. But in my research, I also tried to combine these diagrams like that we create, how that can be used in machine learning process. So as an architect, we have been using diagrams for a long time with this abstract information representing what is essential. And here you can see also this diagram Louis Kahn drew from the traffic of Philadelphia to visualize this kind of traffic flow. And then what we did is actually we invented this tool inspired by the Sankey diagram to make it into a parametric model. So like not just looking at processes, each nodes are processes, but we also looked at different flows of materials, energy, people, creating this diagram. So here you can see some examples of it, overlay between the material processes and also human flows. So students basically identified different flows in their invention of turning waste into a product. And here you can see the diagrams takes different forms, also implemented in the context, and then also actually becomes architecture. And then they inserted these programs of how to transform waste into product as a kind of circular interventions in this long corridor of this sound building into different interventions. So here you can see kind of going through the whole section of student projects intervening this. Also because this building has always been a story where they want to demolish, the city wants to demolish buildings, but there's always a resistance to it. So here, basically they try to create these interventions in this building throughout the building. And this tool now, I mean, we used also in the real settings. So this one is looking at the hospital in Geneva, looking at the flows of the patients and how we can actually transform the spaces to create an optimal flow of the patients and doctors, because it fluctuates throughout the day. So this is one example of how these tools become a real project. And also like moving into Singaporean context, we basically use this tool to understand also the flows that happen within the Singapore. So where could be a potential programs and the sites that could be actually used to optimize and then make the process of material flows circular. And then at the end, of course, it's kind of, we use Gen AI to kind of visualize this concept very fast. So another project is actually looking at the machine learning with also the urban perception. So the flow of human kind of creates this kind of a spatial environment. So the student, master's thesis student, also identified looking at the panorama, so looking at the point clouds of this panorama in Singapore to actually understand this kind of 3D informations rather than typical floor plan driven urban design. So the students was looking at the panorama and this kind of the perception of the different spaces. He basically used the models where kind of it shows the human feelings around these images and combined with the 3D informations to create this kind of to understand these panoramas for his own way of doing the urban design. So here you can see different clusters of this kind of a 3D urban street models are used to understand Singapore and to become actually a tool to generate certain urban context just by looking at the perception. So this flow of this kind of movement also applies into architecture in this project. This one is looking at this artisanship in Kyoto. So what we did is actually looking at this kind of different artisans. And the key thing was this is when the machine learning came in, also trying to understand how these diagrams of these spaces, so each one represents different artisans. So this is very abstract, very conceptual 3D model that's created by the students, also 3D printed. And then using these 16 models, it's really hard to engage with the machine learning algorithms. So what we did is we basically dissected every node to understand the flow, but also the form of these models around the nodes. So here you can see combining all these 16 models and then using a pre-trained model to understand the different forms of different types of form, which I ended up identifying. Machine was able to identify different types of clusters of different nodes, which has distinct shape, but also looking at the graph of this processes. And then by combining those two, we were able to kind of way to optimize, create a new optimized tool to use it in the design process. So by combining the formal and topological relationship, this is kind of examples of different optimizations of the optimal flow of the material, and that translates into space. So here you can see kind of different partitions of the different spaces in existing matcha to create this kind of a circular flow and also have synergy between different flows. And here you can see some examples of student work based on that. So this kind of fascinations with the vernacular architecture is, it also happens in different projects. This is one of the master thesis student work where she looked at this historical buildings in Laos to transform that into physical and virtual spaces. So basically the architectural elements becomes a way to hybridize different contents. So like transforming all these elements, how can we actually make this apparatus to become connected to the rest of the world and in the physical environment. So here's some example of her models and also the project details, 3 buildings that she was working on. But this project became quite interesting because one of the project was working with the artisans, and we had an opportunity to launch a new project with the National Heritage Board. We just got it like last week, but basically how we can conserve and also keep this knowledge that we have with all these artisans in Singapore. So this one is a Latin weaving artisan who he basically weaves with this rattan. So the idea is to actually combine spatial computing with these processes. So like it's not just about the product, but it's about the process, like the knowledge that they have to weave these things, right? So here's a prototype where our researcher is working with artisans to create these elements as a kind of a creative process of not just a chair or something that potentially become even an architectural element, and kind of capturing all these movements that he uses to produce. And this was basically combined with the spatial computing to actually archive the space and also the tools, also the object, also the motions. So this kind of capturing this information in a multi-dimensional way. This is a project that's just going to be launched next year, and quite exciting. And this one is quite cool because it's working with the industrial design professor from industrial designer and also theater arts. So there's a lot of different, it shows like a collaborative effort in the research environment. And of course, I was also working for a big firm like Softy. So I've also had experience in working in large companies, but also I had a chance to also participated in this competition, which was in 2015, Guggenheim Helsinki competition. You guys might know this project, but it was one of the biggest competition ever in the history of architecture. It was like 1,700 submissions or something. And then the office that I was working in Zurich, we got second place, which was like worse than third place or fourth place. But the thing is, after all this, it's very scandalous because it didn't get built. So that's kind of shows that a lot of knowledge gets wasted in this kind of process of competition. So this was the images of the just glimpse of the images of the people submitted, and then this was their website, and then the website has a way to kind of tag different types of competition, but we obviously know that there's only a few of these explanations to categorize as a human, right? So in Switzerland, what I experienced was this kind of very organized competition system where they have to submit this A0 boards, every architect's in the competition, and it's very like standardized, the scale. So this becomes actually really interesting data set because there's consistency in data set. And they always make this kind of booklet, I will show you, but it ranges from 4 to 12 A0 boards, and this is the scene. It's a very fair system where they go in, they look at all the boards, and everyone gets this white massing model. Everyone has to submit this massing model that they can be compared. So a lot of times conversations happen, and even this jury is like measuring the model with a ruler to understand the scale, right? So there is this, I mean, here you can see one of the competition that I was participating, 140 competition entries. And of course we didn't win, but it's hard to win. But once you win in Switzerland as a young firm, like you're good in Switzerland. So it's interesting culture, which I think like rest of the world should actually maybe learn from it. But here you can see actually the model, it became the source of my research with this competition data. So this, from just looking at one model, you can actually get a lot of different information from a single abstract wide model. I mean, you can get like surface areas, you can get volume, you can get like surprisingly a lot of information, even though how much it's going to be costing because there's more surface area than other ones, right? So what I did is basically I collected 600 models of winning entries for 15 years on the school competition. So basically these ones are the winning ones from the first place to I think 13th place in every competition. The process was transforming this data into machine learnable format. So what I did is I used this, back then it was a time where it's still hard to use the ML to understand 3D information. So what I tried to do is using just 600 models, which is not enough because all these algorithms are developed by tens and thousands of models of cups or airplanes, right? So as an architect, how are we going to use this, right? So what I did is like rather than using this kind of a typical uniform point cloud, I was trying to make my own point cloud that can be easy to understand. So the horizontal point cloud was chosen at the end because like on the left is a uniform point cloud, on the right is like this new point cloud where there is an empty spot which represents the horizontal plane, right? So as an architect, we don't need to look at horizontal plane if we don't look at horizontal plane altogether. So like that was kind of explored in this process. So of course, different point cloud types will create a different clustering in latent space. And so basically it was encoded and decoded, and you can see the kind of a very fairly accurate way that machine learns again. So this process of visualizing into latent space became a source that human can actually understand what machine reads from these models. So also the interface, so that like as an architect, when I was talking about how we can actually work with these tools, is this interface is actually one of the biggest, I mean, one of the most important things to visualize when machines, the output of the machine. So this tool was created to actually visualize all these different data sets. So you can just basically search like who's the winning architect, who's the jury, or what year was it. So all these kind of a typical notion of archiving is transformed into a new way of looking at these 3D models in a different way, right? So not just looking at one competition from a book. Now you can look at all these competition. You can just put in 3D model and the training of the results from the algorithms in different types of algorithms. You can navigate through, you can look at it. You can find the relationship between what is the winning form and what is not winning form. So it actually like creates another way of looking at these archives. And now, currently, the research we are doing is actually to implement climate performance in this process. So it just doesn't become just the data, but how can you look at this climatic data in this process. So this is the current research that is happening now to integrate simulations into this machine learning process. I mean, also using different point clouds with the RGB value kind of reduces the size of the models, but understand the point clouds and now in colors, right? So, I mean, of course, this tool also, like, you can mix different forms to create different shapes in between the shapes. I mean, this was a few years ago again, so there's more fairly accurate 3D models that can be used. So what are the different forms that you can actually imagine? And also, can we actually use these reports into the process? So actually the textual description of the projects could also play in a role in this new way of archiving. Yeah. So this was kind of using ChatGPT and combining with this knowledge base information into this interface. And also, I mean, basically this was the image from the Zurich main station. They asked all the architects to donate their wide models, which becomes the knowledge of culture and architecture and that. So recently, like another project that we've been working with the EPFL when I was at Lausanne, and then also with Mijo, is also using large language model to visualize also this kind of globe. So using Google Earth engine data and the large language model to actually kind of identify some what are the existing problems that happens in the globe. So here's the ChatGPT kind of conversation, which is combined with this, and then students were visualizing in a globe what are the crises that happens in the world, but also engaging with the information that gets from the ChatGPT about what are the locations. So here is some kind of a clip that happened as the final results. And also just like recently last week, this is another examples of using large language model and then combining. This one is actually quite interesting. She tried to represent the life of human being, like the life of human after death, into something tangible. So this kind of different archive of and then the textual description of that person gets transformed using the AI to actually create this kind of imagery, and which translates into this kind of a physical model. So this was basically generated from looking at the history of human, but also their objects that they collected or they like, and then kind of transforming into this physical tangible model. So like, this is my last slide because so basically I look at form as kind of a specialized token that embodies a wide range of data and information from cultural norms, semantic meanings, human preferences, climatic performance, energy efficiency, and material properties that could help identify this innate bonds between tangible form and intangible narratives of data that it incorporates. Thank you. Okay, cool. Yes. Okay, you can have the.
Any questions? Yeah. First of all, let me know when you are going to do the competition again, because you already have a winning form, right?
In Switzerland.
So it's Switzerland, right?
Yeah. Only the school competitions. So, yeah.
有问题吗？也可以讲中文，可以中文。Like I have wondering if I look at the different statement of the architecture, like modernism and postmodernism.
Yeah.
I feel like it's kind of quite different in before the digital architecture, right?
Yeah.
The destructive, the play, smooth curve, something like that.
Yeah.
But nowadays it seems like what I have the feeling on your project and research is you use the machine machine learning tools and to understand the nature of the building. And from there, you kind of doing like similar. I don't know if I'm correct. Like similar to like a postmodernism, but it's more than postmodernism. Like means like the use the culture and the tools, and then go beyond to the postmodernism, and like but it's still like historic way.
Yeah.
I don't know. But
Yeah, no, I completely agree because I didn't know, because I do so many different scale, so many different things, but now I found out that my interest is actually very much into form and vernacular, like tradition. So somehow I think that maybe without thinking, that was always in my mind. Because when I do photography, I always go to look at kind of a distinct typology of kind of vernacular forms or history, which maybe I'm just drawn to that. But I think maybe it's also because with the machine learning process, the consistency is also very important. So I don't know if I'm naturally drawn towards to those kind of data sets rather than this kind of contemporary. But now, looking at it with the capacity of the machine learning and AI, I mean, with also looking at shop houses, like we can actually understand maybe new things, right? With these tools that gets developed, right? So it might, like, maybe before it was like, maybe I was narrowed down to something that is very specific, but now I think their capacity is so high that it can adapt to any different environment.
I feel like when like content,
Yeah.
in the end of the content, you see that in a way of creativity,
Yeah.
the quantity might become the quality.
Yeah, exactly. So when I first showed that 3 projects, the Alpine Hut, ETH Zurich, Gangnam, actually the consistency of the data set is different. But we always felt the most successful one was the first one, the Alpine Hut. Maybe it's because it's so simple, but there's a consistency in the data set, right? If you look at the Gangnam block, it's collages of everything, right? So I think that's why when we were exploring, we thought, oh, maybe it was not successful in the Gangnam one using GAN because it was so heterogeneous. But now I think with the tools that we have, can even more see the connections between the different elements, even though it's heterogeneous. So I think that kind of shows in the shop houses. Even though it's a consistent, there is more than just 5 different styles or 6 different styles. So I think maybe my interest will change now.
Yeah. Now it seems like it's still like a rough data, right?
Yeah.
What we could like in the end is like you have a different agent AI,
Yeah.
they kind of talk to each other, and then it's like different MCP. And then in a way that you start to analyze it.
Yeah, exactly.
In the end, it's not like like the like typical computing.
Yeah, very good point. I didn't think about it until just now. Yeah.
Hi, Fred.
Hi, sure.
So happy to listen to your talk, because last time in Cadrea, I only listened to your paper presentation.
Yeah.
I think this kind of project and real cases is much more fascinating to connect with the what students are learning in their studio, everyday design thinking, and all of these. So my interesting would be in the database of the competitions database you just show us. Because of this research, I just can't help but think of some other possibilities. Is that if you have this kind of tool to visualize and to so-called to really look into the nature of each work and of these competition works. And it somehow reveal you some invisible things behind all this work.
Yeah.
And have you seen anything that is specific that you didn't realize before, but when you look at the model, you somehow found out some pattern or some like style, so to speak, is it possible that we can, by looking at this model, we can figure out certain strategy to join this competition to get a better winning opportunity, because there are some lacking spaces, some empty spaces. It might be a possible way to dig into that. So this is somehow when I look at this kind of space, simple space, there's always some vacant spaces, which means probably the opportunities that.
Yeah. I mean, we haven't dived into it. We need to really get into it, because sometimes some competitions, some models are clustered together because of the form. That means the jury was kind of favoring this, and then you can get the list of the jury member that was on that competition, right? And then there's one time, I mean, for example, this example actually has really distinct sometimes forms, right? Which sometimes juries might be actually open to all these different strategies. And then also in the Swiss competition, there is also a rule. They have a joker. So this project doesn't fit with the competition, but it's a good project. So sometimes that happens. So you can start to see these things that we didn't see in this model, which we really need to go in deeper with this. So it will come.
That's great.
Yeah, it will come.
Looking forward to it.
It will come. And also looking at the climatic data opens up another door in terms of are people actually even thinking about climates when they're, because the culture is, they look at this wide massing model, right? Even though they look at the architecture, they naturally look at the form, right? Without even thinking about it. They don't talk about form, but they see the form, but the conversations happens around the form, right? So it starts to open up the things that we didn't see, which I think I need to go back and look at it even further. It's WIP.
Yes.
Still work in progress. So.
Yeah, this really opened a lot of opportunity to look into all these works, and that actually lead to my second question. Is that usually when we look at how architecture school or architect in practice, how they are using AI in their daily practice right now is, to be honest, from my point of view, not everyone, but from my point of view is majority of the usage quite superficial. They are just using it to generate some image, or using that to making some rendering of their drawing.
Yeah.
And it seems like it's just just like the very beginning of the computer-aided design in 20 years ago, people just use it to replace draftsman, right?
Yeah, exactly.
So right now that most people are doing that, but I think what you show us is what I think is the most valuable thing, is that you actually inform us about the meaning, the interior construct of how design is doing, all the design thinking stuff, and how to connect all these relationships and meanings, style, everything. And is that actually you use AI or machine learning as your very powerful assistant that is proficient in certain thing? And although I think that's the very ideal way of doing research and doing design in the future, but it seems that there's a gap during our like the training
Yeah.
or even the
Yeah.
architect's examinations process.
Yeah.
Because the examinations, the licensing process is not still reflecting
Yeah.
all these new tools.
Yeah.
So, what from your point of view, what could be the possible way to improve that or get everyone closer to this?
I think for AI integrating into design process or any other work, what is important is to look at the audience who's using it. So, like currently I'm teaching like first year, second year master thesis, and then the way they will be using AI is different. So some part it becomes more advanced, some part becomes very conceptual. So I think that finding appropriate usage of tools into certain demography, but also task, is I think quite important. But also the creativity lies in how do you use these tool and then create a framework. So it's not the results; it's actually how do we do the methods to use these tools is I think the invention. That's what's make all these conferences interesting because everyone is using the same tool but differently, right? So I think that's the geniosity of using these tools. But also a lot of times people kind of stop just using a couple times and that's it. They sometimes if it doesn't work they just. But if you really want to get into use this as a tool, you really have to investigate. Even just prompting, right? You really have to spend time in, and once you get to the point you feel comfortable, it becomes a really powerful tool. So I don't believe it in as kind of it's used just for quick visualization. It's basically the same thing. Some people use better Grasshopper than other people because so it's just a tool. So for me, so it's and then technology is developing so fast. There's more tools gonna be. And as an architect, we just have to find the creative way to use it. That's the hard part, I think. Yeah. So.
大家可以问问题，然后可以问提问。讲英文最好。
就是我觉得那个他对于就是形态的研究很完整，就是除了对建筑整体的，就是以整体去看，以 geometry 去看的，以及从建筑元素、人体尺度去看的，比较无论是窗框啊，或者是建筑的沿条之类的。我是想问说，对他来说有没有可能什么样形式的或什么样 geometry 的对人的品质，对他来说有没有因为他前面有形容词，就他有提出了形容词这件事情去分类，但是他来说有没有什么样的标准？他在判断就在什么样的情境下，什么样的 geometry 是好的？
He's appreciating your analysis about the form and also all the like style and like even the elements of architecture, and put that all into the analysis using your methodology. And he's curious about how do you determine the quality of these the space or spatial quality. In terms of, for example, you mentioned about the adjectives that you use, and is there any like qualification or any ways to quantify that or to describe that?
I mean, that's why I think the title we was mentioning was the human perception. So I think our design intuition is still machines cannot understand. So we can guide the machines, but at the end we still have to assess as an architect. That's why I don't think we're going to be out of job. Because like there's so many layers in the architecture that we have to think. So it's not just an image. So that's why I think the only way to kind of, we can quantify like performance of the building, right? But then we always have to negotiate between the aesthetics. Sometimes aesthetics is more important, more weighted. So I don't think we can actually quantify. Maybe there is a way to quantify later on. Maybe this model can actually, computational model can actually quantify. It might actually, like if you put a form in here, it will put the form into where it is, right? So I think, we can quantify at the end, but at the end is what human is the one who decides, right? So you can have a competition boards and then you can have a best climatic performance. But jury might not choose it because there's enough money to build maybe a design that is more expensive, but it's not as efficient as the other one. So I think there's always this things that human plays in a role, and money plays in a role, and culture plays in a role. So it's at the end, I think we can only quantify to a certain degree, which this project tries to push the limit to how much can we actually quantify. So that's why I think I need to go back to this research and see one by one, because it was a research, so I couldn't go in deeper. There's a time limit, so, but yeah.
So this reminds me of the in industrial design. There's a methodology called concept engineering. It's called affective engineering.
Oh, I see.
It's how people feeling the emotional reaction to that. They have a certain methodology to using even survey and interviewing, and then they're trying to come up certain descriptive or adjective, and use certain quantification method to do that. So would that be possible with that?
It is possible. Like for the project that I was showing, this last project, which ultimately tries to quantify the current environment. The current environment, but also, but then during the jury process, with the guest, they were talking about the actual images, how not good the design is. Even though we created all these ways to calculate numbers, how do you find correlations between the lighting, sound, everything? But at the end, the juries look at the final redesign, and then machines is not good. That's the reality. So even if we include that research, this human emotions and perception, there's always still feel like the lens of designer. So we can do up to a certain degree, but those science also helps to, so one of the other students was trying to have the sensors in the brain to use it to emit Gen AI. So that's also another project. How can we actually use the prompting, but also different human behavior. So how the eyes move, it figures out the emotions through the capturing your face and checks your brain waves. And then the Gen AI would change not just by prompting, but also this. So, but then you always have to go back as a designer if this makes sense or not. So I feel like this connections is going to happen more and more. Yeah, so it was criticized. But the work is brilliant because it's an attempt to control the images that we, not just by prompting, but actual scientific values. Right? So, yeah.
我刚才说的那个，后来追问的那个是指，在工业设计领域里面有一个研究方法，就叫感性工学，是日本发展出来的 concept engineering。那他现在研究的就是人如何用像情绪用词啦，或一些主观的方式去描述一个物件或使用的感觉那种事情。那他们用的也是用统计啊，用问卷这样方法，但他们最后还是可以理出一些头绪，说哪些词是最重要的啦。但是背后可能会涉及到一些语义的研究，说怎么让这个语义的一致性是比较好的。所以背后其实有一整套的研究方法可以做。不过刚刚那个 Fred 讲的还是一样，就说所有这些研究方法都是在 描述设计师跟人的，它其实在捕捉我们在描述的那个过程。所以你是不是真的很了解，完全要看，还是从我们的诠释去理解它？对，倒不是说那个方法好像就完全就是很信任它，其实它还是蛮仰赖诠释。
Yeah, and I think their comment is very important because at the end, if it doesn't work as a designer, then we have to change something, right? We have to make it more meaningful. So it's still important point. Yeah. Okay, cool.
Now, you can still modify the basic information, and the system will generate a new version of the image accordingly. Adjusting the sliders will also not be
好啊，那我们就Thank you, Professor Kim.
Thank you. Thank you.
Talk.
Thank you. All right.
From the question, I go like the European framework for architecture to use or like to increase the precision.
Yeah.
If that is your angle.
Yeah.
我再跟同学那个各位同学也留意一下，可能有些同学还没有来，就是也可以同学再提，因为我们接下来还有好多场演讲。那这些演讲呢，刚好都聚焦在最近比较新的这些议题，当然也都跟 AI 可能有点关系。但像这个礼拜4会来的老师，东京大学这位老师，他是在日本目前在进行这个很大的有关建筑资讯的一个大的改革当中正在做，他们也跟产业有很多的合作。所以他也会来分享目前在日本的一个最新的一些发展，已经走向不是像台湾我们现在走 BIM 2.0嘛，但他们已经不是只有这个了啊，已经跟所有包含跟文化跟很多的产业都产生关联性了。那还有他自己也做了很多很有趣的研究，也是在这个领域学术界也主导过很多很厉害的。所以这些老师们来分享的时候，其实就短大概都是1个小时以内。大家稍微来听听，稍微可以扩展一下你们所知道的事情，以及也许会开启你一些对不同的兴趣。更重要的是，有时候你会听到一些跟一般我们在所上老师讲的不一样的事情，或更多的。我觉得这个是非常有帮助的。以后接下来这几场再请大家留意一下讯息，然后我们再来多接触。Yeah, I'm mentioning about Ikeda-san will come in this Thursday, and also Toyoda-san, it will be the next week. Yeah, he will come here and. Yeah, and also, do you know Chen, Professor Chen in SIT? Probably no, right? Yeah, one of my friends. He will also come in December. Well, he is a professor in SIT. SIT is a new university in the Singapore Institute of Technology. Yeah, it's a new campus. Their new campus in Punggol area. Yeah, it's very close to the airport, and that university is very focusing on industrial connection and very practical research. And he's is quite into the all about the energy, like lighting and also sustainability. And well he's a Taiwanese, so come back also sharing something with us. Yeah. Cool. Great for that. 12月12号也还有另外一位是台湾人，那这位老师钱思成老师，他是在新加坡理工大学他的专业领域是在永续，但是永续里面跟建筑的健康、人的健康啦，照明这方面做了很多研究，还有他跟新加坡政府有很多他大型专案的合作，所以也会跟大家分享他们很实际在新加坡在进行的一些专案。那这些我想都是非常实务啦，有机会大家也可以多听听这种整天在学校学的东西，到底人家他们在实际的进行当中很多实验专案在跟政府在做的是什么事情。那未来如果有机会在台湾推行，台湾通常做的会比新加坡慢一点点，或慢很久。也是意味着未来我们也有机会往这个方向做，大家也可以多了解。OK，Thank you， 谢谢大家。
之后如果可以关注他的那个 IG 啊，或是他的 lab，he's going to have maybe have an open position, maybe in the near future. Yeah. We need a good, good guy, strong guy. Are you sure? It's too warm. It's hot.
Now we are much comfortable.
It's perfect here.